Hey guys, so follow along with me and fill in these notes if you've printed them, or write these facts down in your notebook. You will be responsible for these ideas on your graded assignment Google form this week. So you'll want to ask questions in class if you need to, and definitely try all the practice problems after this video. Consecutive angles on a line, sum to. That fact is 180 degrees. And the reason why we know this is because we know that there are 360 degrees in a circle, and if we look at these three angles here, they are sharing what looks like a half circle. If I can draw a half circle over the angles, and those angles are formed along a straight line, which we know is a straight angle, then they are going to all add together to make 180 degrees. And that fact can be helpful because let's say I want to find the value of x in this picture. I could do 50 plus 2x plus 60, and I know that my equation is going to equal 180 degrees. Solving it quickly, if we combine like terms, we get 2x plus 110 is equal to 180. Then we would subtract the 110 on both sides, leaving us with 2x is equal to 70. Dividing by 2, we would obtain that x is equal to 35 for the diagram shown. The next kind of fact about angles that we need to know is that angles around a point are going to sum to 360 degrees. I mentioned before that a full circle is 360, and check this out. You can draw a full circle over this angle, this angle, this angle, and this angle, because they're all centered at this point. So if we want to figure out what the value of x is in the diagram here, we would take all of our angles that are marked, add them together, like so, and set that equal to 360 degrees. There is the simplified version of my first equation. They are equivalent by combination of like terms. I'm going to subtract the 250 next. So there's subtraction of 250 on both sides, and next we're just going to divide by 3. And 110 divided by 3 is kind of a funky number. It's 36.6 repeating. It's a little pausing in the video so that saves us a little bit of time as I do the equivalent equations for you. The third angle fact that you're going to be responsible for is one that I find comes up a lot in this course. It's very, very important. Vertical angles are equal in measure, and what I'm going to point out to you in class a lot is that vertical angles, basically you could color them like this, and they look like two V's that are touching in that manner. So they're going to be equal in size. So if I wanted to solve this equation, we would simply take 74 and set it equal to 2x to find the unknown quantity x in this one, and we would divide both sides by 2. And that's going to give us 37 is equal to x in this case. So again, vertical angles, they are formed when two lines intersect. Linear pairs are just that. They are a pair of angles that form along a line. So keyword is pair, that means there are two of them, and linear means they're on a line. So if you look over here at the diagram, you have this half circle idea again, just like we did up here in the consecutive angles on a line. This one is just the fact that there are only two angles, 1, 2, instead of 3. So we would still set this one up with the same sum, 9x plus 3x should add up to 180 degrees. Then we're going to combine like terms and solve for x. To do that, we're going to divide both sides by 12 naturally, and x is equal to 15 when we're finished. The fill-in on the line here, instead of saying add to 180 degrees, we often say that linear pairs are supplementary, and if you remember what that means, it means that they add to 180 degrees. Question number 1 starts off with AB is perpendicular to FE. This symbol means perpendicular, and we're going to discuss that more in class this week with our lessons. So perpendicular lines are very important in geometry. What they indicate is that they form 90-degree angles when these types of lines intersect. So in this case, when they're asking us to find the values of C and D and explain our answers, there is a letter D in the picture. I'm going to start with D, and D is right next to this little square here. And you may remember seeing squares in some diagrams in math in your former courses, and that square indicates 90 degrees. So D is a very simple answer in this problem. D is equal to 90 degrees because it's next to the little square. And also, I'm looking for you to recognize that because these lines are perpendicular, that is why angle D is a 90-degree angle, because perpendicular lines form 90-degree angles, we say, in geometry. So there's my explanation. D equals 90, perpendicular lines form 90-degree angles. I guess I could have threw the word because in there, but that takes longer for me to write. For the C angle that we see, this has to do with the opposite of what we talked about on the last slide. We lastly spoke about the word supplementary, and that angles that are supplementary add to 180 degrees. Well, if we want to figure out what C is in this picture, we have to recognize that these three angles right here are also sharing a square that's not drawn in, but it is there because of the fact that our perpendicular lines form 90-degree angles. And these angles are all sharing that square, so we say that those angles are complementary. To figure out the value of C, you can do a little side work in the form of an equation, or you can do some arithmetic. I generally tend to use equations, so 40 plus 36 plus C, some angle we don't know, has to add to 90 degrees because they are complementary angles. We're going to combine our like terms to get 76 plus C is equal to 90, and then we're going to subtract 76 on both sides, and that will reveal that C is equal to 14 degrees. And I would say that C is equal to 14 degrees because the angles are complementary. And that's how you spell complementary. The next question, number 2, given lines M and R, justify the value of B. Justify in geometry and in all New York State courses means to show work. So we have to show how we get the value of B. To find the value of B, I would start with the fact that I know that this angle right here is 40 degrees. And that angle is adjacent, we say, or next to angle B. Notice how when I drew an arc for angle B and the arc for the angle that's 40 degrees, they are sharing a half circle. So we know that they are a linear pair. They are two angles on a straight line next to each other, and that means they add up to 180 degrees. So justify, the best way to show me this justification is B plus 40 has to add up to 180 degrees. You can also just show me subtraction of 180 minus 40, which is what I'm about to do, and tell me that B equals 140, and that would be perfect. So B is in fact 140 degrees, and I'm going to put that on my picture. Explain the value of C. Explain is different. I have to do more of a sentence, kind of like in number 1, or some more written language. Explain the value of C. For me, I'm going to color with a yellow coloring tool, angle C's little corner, and point out that this angle has a matching kind of V that would be end to end with this V. So in that situation, when that happens, we say, according to our little facts that we went over in this lesson, that those angles are vertical and that vertical angles are equal. So I'm going to say that C is equal to 40 degrees also because vertical angles are equal. Vertical angles form when two lines intersect, and they're basically the angles that are across from each other. Last question on this slide is the toughest. The ratio of two supplementary angles. This is going to be a big question on the graded assignment this week. So let's jump in here. It's very, very easy to do a ratio question, and I often make kids laugh when I say this. You have a 4:1 ratio. You've got nothing to work with right now to make an equation. You just have 4 and 1, and that's the only numbers in the verbal prompt. So this is the point. We want to make an equation. So to do this, I say we slap an X. You slap an X next to the 4 and next to the 1. And the reason why I make kids laugh is because it does kind of sound inappropriate, slap an X. So you have 4X and 1X, and now hopefully you'll never forget what to do when you see this word here. Slap an X next to the numbers. So now you have 4X and 1X, and that means that you have one angle that is 4 times as big as the other, basically. And you have 4X and 1X that we're always going to add our angles together. And this is the other key piece to the puzzle. Our equation is going to equal whatever supplementary angles equal, and we went over that so far in this lesson, and that is 180 degrees. So once you've set up your equation, you're going to obviously solve by combining like terms and dividing both sides by 5. And that answer is 36. And then once we get our answer to our equation, this is what's also tough about these questions. It says find the angles. So x equals 36 is not our angles. Our angles that are supplementary are 4x and 1x. And to find what they actually measure, we need to take what x equals and plug that into your pieces of algebra. So 1 times x would be this one angle, and 1 times 36, let's be honest, is silly. That's 36. The other one is 4 times 36, and you may need a calculator for that, and that result should be 144. So one angle is 144 degrees, and the other one is 36 degrees. 144 and 36. I'm just going to restate them over here so that I've clearly answered the question. And it should remind you a little bit of algebra. It's kind of like a modeling cycle. First, you set up your pieces of algebra to represent your angles. Then you write your equation, you solve it, then you take it back to the algebra and substitute to find your angles. Okay, we've got 2 more to do, and I'm going to go a little bit quicker here. We have 2 complementary angles in a ratio of 4 to 5. If I see that word ratio, I'm going to slap down an X next to those numbers. 4x, 5x. These represent our angles. I'm just putting a comma in between them. To set up our equation, we have to take them, add them together, and we're going to look to this word to tell us what they add up to. The CO in complementary can easily be made into 90. That's how I always remember that it's 90 degrees. And so we have a 90-degree total for our 2 pieces of algebra. Going to add our terms together because they are like. Divide both sides by the 9. X is equal to 10, pretty simple. We're going to take that 10 back to our pieces of algebra to discover what are the angles. Now this question asks for the greatest angle. I just plug it into both because then I'll never get it wrong. So I'm going to substitute my value 10 in for x. 4 times 10 is 40, so one angle is 40 degrees. 5 times 10 is 50. The other one's 50 degrees. And now the greatest of those angles, obviously, is the larger number, 50 degrees. But again, it's easier to just always plug into both of the pieces of algebra. That way you never make a mistake if it's a graded performance task. Number 5, the ratio of 2 complementary angles is 1 to 2. Here I go, ratio. I'm going to slap the x down. 1x is one angle, 2x is the other angle. We're going to add them together and set that equal to whatever complementary angles add up to. Oh, that's right, 90 degrees. Combine like terms. Divide both sides by the coefficient 3. X is equal to 30 degrees, or 30. Take it back to the algebra. Substitution, 1 times 30 is just going to be 30 degrees for one angle. 2 times 30 is going to be 60 degrees for the other angle. And it said find the angles, so we've done our job. 30 degrees and 60 degrees. And it should make sense because 30 and 60 add to 90, same as the 40 and 50. 40 and 50 in question number 4 also add to 90, so we can feel like we can check our work. Okay, remember to try all of these problems in your notebook. Try the practice problems listed after that task, and then make sure that you have labeled all of your work nicely in your notebook so that you can call upon these questions when it's time to do them on the graded assignment by yourself.